Let's do another quick code tracing example. When you're tracing code, it's really important that you don't let your understanding of what you think is supposed to be happening influence your judgment about what will the computer actually do when it runs the code. Because usually when you're debugging, you have a bug. That means there's a problem. And so if there's a problem with the code, maybe what you think is happening, or maybe what you think should be happening, isn't actually happening. That's the whole point. But it's really hard if you've written some code not to let your own understanding of what the code is supposed to do. Like, it's hard not to just see that meaning. So let's look at this example. Let's pretend that we have implemented code for a two-player game, and there's a variable that's an integer called player turn that stores whose turn it is. So it could be either 1 if it's player 1's turn, or 2 if it's player 2's turn. And we have part of our code that's supposed to switch the player turn. You know, maybe it's the end of player 1's turn and we're trying to switch to player 2, or vice versa. So we have this code, and it seems sensible enough if you read it. You say, if the current player's turn is 1, let's make it 2. And if the current player turn is 2, then let's make it 1. So it seems like this should just flip-flop whoever's turn it is. But if you actually trace the code line by line, you'll see what's happening. Because remember, computers are dumb. They will robotically execute exactly what you tell them to do, one step at a time. So let's imagine that player turn actually does equal 1. We'll run this line. This will evaluate to true, because player turn does equal 1. So then we'll save 2 inside player turn. So now player turn equals 2. And then we'll say, oh, is it true that player turn equals 2? And then we'll save 1 back inside player turn. So at the beginning, we were imagining that player turn contained 1. We put 2 in it, but then we put 1 right back inside it, and then at the end of this code block, player turn still has 1. So we ran the code, but we failed to switch the player turn. That's the bug. So we can fix this by putting an else if, or even just an else. Let's just put an else. So now it says, let's do the same code tracing. So let's pretend that player turn contains 1. So we say, if player turn equals 1, the answer is yes, because we were imagining that it contains 1. So now we put the number 2 in it, we're done, and then we're just done with the whole code block. We don't evaluate else, because else is what you would do if that statement was not true. So we have successfully swapped the number inside player turn. Let's pretend player turn equals 2. So if player turn equals 2, we want to flip it to 1. So we say, is this true? And the answer is no, because player turn equals 2 right now. So we go to the else, and we put 1 inside. So it's done what we want in both cases. So I think the lesson from a debugging perspective is you can read the code like English, and it seems very sensible. We do want to say, if player turns 1, make it 2. If it's 2, make it 1. But the problem is you are bringing in your human understanding and thinking you wouldn't ever do those both at the same time. And so keeping in mind some basic patterns, such as the if-else or the else-if, that are designed to prevent you from doing the same thing over and over again, or that are designed to help you do only one of several options. Okay, I hope that was helpful. Oh, let me say at the end, you can if your goal is just to do this in an extremely short way, there's an even shorter thing that you could do. If you were going to make this a Boolean variable called player 1 turn, and if that's true whenever it's player 1's turn, you could just say player 1 turn equals not player 1 turn, like this. So now let's erase this. So if player 1 turn was true, the not would turn it false, and you'd save it here. And so you'd turn true into false. If player 1 turn were false, the not would turn it into true, and then you'd save it to true. So this would flip-flop true, false, true, false, true, false each time you hit it for player 1 turn. You could do the same thing using our original variables, but it involves a bit of a trick. Let's look at this. So what did I call it? Player turn. So player turn equals 3 minus player turn. So now imagine what that's going to do. Imagine that player turn equals 1. If player turn equals 1, then we'll say 3 minus 1 is 2, and save that here. And so player turn becomes 2. So when it's 1, it becomes 2. Let's imagine it's 2. If player turn equals 2, we say 3 minus 2 is 1. We save the 1 here. So when player turn is 2, it becomes 1. So this mathematical expression is flip-flopping 2 to 1 and 1 to 2. The problem is it's like not very clear just to look at it that that's what it's doing unless you've seen this trick before. So from a code readability perspective, I actually think that even though the if-else statement is longer, it's actually probably better code. Because if you're going to write this for other people, including yourself 6 weeks from now, you're not going to remember what this is about. And you're trying to reduce the amount of focus you need while reading your own code. There are fewer places for bugs to hide when your code is as absolutely simple to look at as possible. So if you're going to do something clever like this, if you feel compelled and you can't not, at least put a comment explaining what the idea is here. But I actually think that the original solution we came up with is going to be cleaner code. Okay, hope that helped.